All right, we're going to continue our work with polynomials, and we're going to expand upon multiplying polynomials. So last time we were just multiplying when we had a single term, a monomial, all right, into a polynomial. So we're going to build off of that today. So to get you thinking about that, we have two problems very similar, all right, in our open here to what we did in our previous lesson. So if you guys would, go ahead and pause the video, complete these two problems, flip it back on, and we'll see how you do and how that leads into our conversation for today. All right, so when we look at what you have here, hopefully, all right, you distribute it like you did last time. So 2x times 5x, so 2 times 5 is 10, x times x is x squared. 2 times 1 is 2, and then I just have the 1x here, so I get 2x. Now on part 2 here, all right, negative 4 times 5 is negative 20, and I have just the 1x here, and then negative 4 times positive 1 is negative 4. All right, so that's the distribution problem. All right, so now, let's take this and talk about what's really happening when we multiply, all right? So now to do that, we're just going to look at a very basic problem here, all right? So when we look at our problem here, all right, so let's think about 6 times 10, right? And hopefully we all know 6 times 10 is 60. Now let's think about what's really happening here, right? And how that connects to the distribution property. So notice that I can write 10 lots of different ways. I could write it as 7 plus 3. And then notice if I did that, then I have a distribution problem like I did above, right? So 6 times 7 is 42, and then 6 times 3 is 18. And then because 42 and 18 are like terms, I can add them, and notice I still get 60. All right? Now notice, but I could write 10 a different way, right? I could write it as 5 plus 5. And then notice once again, if I distribute it, 6 times 5 is 30, 6 times 5 is 30, and then 30 plus 30 is 60. Or I could write it as 12 minus 2, right? So 6 times 12 is 72, and then 6 times negative 2 is negative 12. And 72 minus 12 is 60. All right, so notice there's an infinite amount of ways I could rewrite 10, right? And no matter what and how I wrote it as 10, I would always distribute 6 and get 60. All right, so hopefully you see that. All right, now notice what happens though if we write both the numbers as an addition or subtraction problem. So, right, we said that we could rewrite 10 as 7 plus 3, but what if I decided to write 6 as 2 times 4? Or excuse me, 2 plus 4. Now, notice what happens now. If I look back, right, if I had one number here, I would distribute the one number, but now I have two numbers, right, and I have to distribute both of those numbers. So watch what happens now. I have to do 2 times 7, and that's 14, and I have to do 2 times 3, and that's 6. And then I have to come back and do 4 times 7, which is 28, and 4 times 3, which is 12. All right, so I get 14 plus 6, which is 20, plus 28, which is 48, plus another 12, which is 60, So how is this happening? What is really happening here? All right, and so what's happening is I'm distributing two things, right? And I still get to 60. All right, so now I have 3 plus 3. All right, now another way of doing this, all right, and I'll show you in the final problem here is notice I could do 3 times 5, that's 15. 3 times 5, that's 15. Well, then I have to come back and distribute this 3 to 5, that's 15. I have to distribute 3 to 5, that's 15. 15 plus 15 plus 15, that is 60. All right, so one way of conceptualizing this, right, is I'm distributing 6 to everything in here, right? But now there's two pieces to 6. So I have to distribute both of those pieces of 6, all right, in order to get the whole 6 here. Now, here's the other way you can think about this, right, is that I can think of it as two separate problems. I can kind of ignore the one here, and I really have 5 times this, right? So this is really 5 times everything here. So this is really 5 times 12 minus 2. And then I can ignore the 5 and say, okay, now I have 1 times all that. So then I have to distribute 1 to that. So that'd be plus 1 times 12 minus 2. And then notice 5 times 12 is 60. All right, 5 times negative 2 is negative 10. 1 times 2 is 12. And 1 times negative 2 is negative 2. All right, so 60 minus 10 is 50. 50 plus 12 is 62. 62 minus 2 is still 60. All right, so we still get the same result. As long as, right, as long as we make sure we distribute everything. So now let's see, how does this tie back into the opener? All right, so notice we had these two separate problems up here. I distributed 2x to 5x plus 1. I distributed negative 4 to 5x plus 1. So now when I look at what's happening here, now I have 2x minus 4 times 5x plus 1. So I need to distribute the 2x to 5x plus 1. So that would be 2x times 5x plus 1. And notice that looks just like what we did above. But now I have a second piece here, right? This negative 4 times all of this as well. So that's negative 4 times 5x plus 1. So I have these two pieces, right? Because these two pieces create some number. I just don't know what that number is because we don't know what x is. But it's still some number in the same way 2 plus 4 was some number. And then I just do my distribution like we did above, right? So 2x times that, that's 10x squared. 2x times that is plus 2x. All right, so notice that matches exactly what we had here. If I distribute the negative 4, I get negative 20x, and I get negative 4 when I distribute here the same way up here. Now, here's where this is slightly different than when we're working with just numbers, because not all of these are like terms. So notice there are no other x squareds, so I'm just going to bring that down. But I do have two like terms in the middle, because I have 2x minus 20x, and 2x minus 20x would be negative 18x. And then negative 4, there's no other numbers to combine that with, so I bring it down. And there's my result. All right, so we're really doing this idea of really distribution, all right, distributing two things, right? So if I have two things here, I have to distribute both of those pieces to the second guy. Now, here's where the area model comes back in. So you can obviously write it out just like I did here, okay? But here's the other thing we can do to make sure we account for everything is write that out. All right, as an area model. So I could put 2x right here and negative 4 here. I could put 5x here and I could put positive 1 there. And then notice I can multiply to get the area of each rectangle. So 5x times 2x, that would be 10x squared. 5x times negative 4 is negative 20x. 1 times 2x is 2x, and 1 times negative 4 is negative 4. And then notice I can still see my like terms here. And here they are. They're along that diagonal. So I can then combine like terms. 1x squared, or excuse me, 10x squared, and then 2x minus 20x would be negative 18x, and then we get negative 4 here. All right, now the area model, once again, just kind of helps you, all right, make sure you can account for everything. All right, so you can do it this way, you can do the area model. All right, and then that's what we're working on today. All right, so let's flip the page here. All right, and I'm going to do the first couple here with the area model, just so you can see that. And then I'll do a couple more with kind of the distribution model, all right, like I did the first time. Okay, so now, if we're going to do x plus 3 times x minus 2, that would be x plus 3 times x minus 2. So I would do x times x, and that's just 1x squared. X times 3 is a positive 3x. Negative 2 times x is a negative 2x. And then a negative 2 times 3 is a negative 6. And then notice if I look for like terms, I only have one x squared term, so I'll bring that down. But here I have two x terms. So negative 2x plus 3x is a positive 1x. And then I only have one number term, so I get negative 6 here. All right, and then that's what you have. Now, if you had done the distribution model, you would do x times that, so it would be x times x minus 2 plus, and then I would do 3 times this guy, 3 times x minus 2. So x times x is x squared. All right, x times negative 2 is negative 2x. 3 times x is 3x. 3 times negative 2 is negative 6. And then you see that your like terms are in the middle in the same way that we had our like terms on the diagonals here. So I still get x squared plus 1x minus 6. So you get the same answer either way. All right, but we want you to see different models so you can kind of build a conceptual framework around that. Okay, now moving on to number 2. I have 2x minus 3 times 3x plus 5. So you can see I have, all right, my area model already set up here. So when I do this, so 3 times 2 is 6, x times x is x squared. 3x times negative 3 is negative 9x, all right? 5 times 2x is a positive 10x. 5 times negative 3 is negative 15. All right, so that's the multiplication. Now, all right, and for some of you, this is going to be cleaner than setting it up like this. So you can see those products very quickly and easily here. And I can see my like terms lie along the diagonal here. All right, so I get 6x squared 10x minus 9x or 10x plus negative 9x is positive 1x. And then I have my number term, which is negative 15 here. All right, so moving along. Now, sometimes we have to interpret and rewrite before we ever begin the problem. So notice here I have 4x plus 6 squared. So I have to rewrite that so that it is a product. Now remember, if something is squared, that means times itself. So this is really 4x plus 6 times 4x plus 6. All right, and I'm just going to create my area model real quick. All right, so I'm just going to create my box, and I know it needs to be 2 by 2 because I have two terms and two terms. So 4x plus 6, 4x plus 6. All right, and now I can just do my distribution. So 4 times 4 is 16, x times x is x squared. 4x times 6 is positive 24x. Oh, let me get you back into focus here. Maybe. Here we go. There we go. 6 times 4 is 24x again, and then 6 times 6 is 36. And then once again, we're looking for those like terms. All right, so I only have my 1x squared term. I'm going to bring that down. My like terms are right here, right? 24 plus 24 would be 48x. All right, and then I have my 36 here, and I just bring that down. And that is the result. All right, moving on to problem 4 here. All right, so once again, a binomial times a binomial. So I'm going to just create a 2 by 2 area model here real quick. All right, so 3x squared minus 7x times 5x cubed plus 2. And then I'll just distribute here. 5 times 3 is 15. Now, x cubed times x squared, remember that would be x to the 5th, right? So I have 3 x's times 2 more x's, that is 5x. 5 times negative 7 is negative 35. X cubed times x, remember this is to the first power. That means I would have 4 x's to multiply. 2 times 3 is 6. I have just those 2 x's right there. And then 2 times negative 7 is negative 14, and then x to the first power. Now I'm looking for like terms. Now remember, we want to typically write things in descending order. So I have a 5th power, no other 5th power, so I'm going to bring that down. Then I have a 4th power here, but no other 4th powers, so I'll just bring that down. I don't have a 3rd power, but I do have a 2nd power of x here, and so I'll bring that down. And then I have my my 1st power x right there. So in this case, all right, I didn't have any like terms to combine, and that happens sometimes. All right, so don't try to force it. All right, so just analyze and look at it, and if you do have like terms, combine them, and if not, just move on. All right, let's do one more together here. So let's look at problem 5 here. All right, so 4x squared minus 3 times 4x squared plus 3. I'm going to do my 2 by 2 area model real quick here. All right, so 4x squared minus 3, 4x squared plus 3. All right, so now 4 times 4 is 16. X squared times x squared would be x to the 4th. Okay, 4x squared times negative 3 would be negative 12, and then I just have the 2 x's, all right, from right here. 3 times 4 is 12 again, and then I have the 2 x's right here. And then 3 times negative 3 is negative 9. So now, once again, writing things in descending order, I have an x to the 4th here, so 16x to the 4th. Now notice, now I have 2 x squareds right here, all right? Now 12 minus 12 is 0, so there are no more x squareds, right? So I don't have to write anything. So if you combine like terms, you get 0, don't write anything at all. Just move on to your next term, and in this case, that would just be the negative 9 right there. All right, so that's your introduction to, all right, multiplying binomials. All right, if you have any questions, have those ready, highlight any problems that you might have with this, and then we'll get to those questions in class.